Right now, as you're watching this video, you think you're sitting in a chair. You think you're holding a phone or looking at a screen. You think matter is solid, real, tangible. But what if I told you that you've never actually touched anything in your entire life? What if the chair you're sitting on, the ground beneath your feet, even your own body, are nothing more than force fields pushing against other force fields? What if everything you've ever experienced as solid matter is actually just empty space with invisible forces creating the illusion of substance? Here's the truly mind-bending part. When you zoom into an atom, you discover that it's 99.9999999% empty space. If an atom were the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be tiny specks orbiting at the outer walls. Everything in between? Absolutely nothing. Just void. And yet somehow, this nearly empty nothingness creates the sensation of solidity when you touch a table. A physical world, as you know, it might not be physical at all. It might be nothing more than a symphony of invisible forces performing an elaborate trick on your senses. And by the end of this journey, you'll never look at reality the same way again. Before we dive into this reality-shattering exploration, smash that like button if you're ready to have your mind completely blown. Subscribe and hit the notification bell, because we're about to venture into territory that will fundamentally change how you perceive existence itself. And drop a comment telling me what country you're watching from and what time it is where you are right now. I'm curious to know how many of you are watching this at 3 in the morning, unable to sleep because you're already questioning reality. Let's build a global community of curious minds together. Let's start with something you think you understand: touching. When you place your hand on a table, what's actually happening? Your brain tells you that your hand is making contact with solid wood. You can feel the texture, the temperature, the resistance. It seems undeniable. But here's where things get weird. At the atomic level, your hand and the table are not actually touching, not even close. What you're feeling is the electromagnetic force between the electrons in the atoms of your hand and the electrons in the atoms of the table. These electrons have negative charges, and like charges repel each other. The sensation you call touch is actually the feeling of electrons pushing away from each other with incredible force. Think of it like this. Imagine two powerful magnets with the same poles facing each other. When you try to push them together, you feel resistance. You can get them very close, but they never actually touch. That's essentially what's happening every time you touch anything. Your hand's electron cloud repels the table's electron cloud, and your nerves interpret this repulsion as contact. In 1909, Ernest Rutherford conducted his famous gold foil experiment that shattered our understanding of atomic structure. He fired alpha particles at a thin sheet of gold foil, expecting them to pass through with minimal deflection if atoms were solid, uniformly distributed matter as previously believed. Instead, while most particles passed straight through, some bounced back at extreme angles. Rutherford himself said it was as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. This experiment revealed that atoms are mostly empty space with a tiny, dense nucleus at the center. The implications were staggering. If atoms are mostly empty space, and you're made of atoms, then you're mostly empty space. The chair you're sitting on is mostly empty space. The earth beneath your feet is mostly empty space. Everything solid is actually an illusion created by forces. 9 o'clock, first retention hook. But here's where it gets even stranger. And this is something that will fundamentally shift your understanding. If matter is mostly empty space held together by forces, then what are those forces made of? Are forces physical things? Can you touch a force? Can you measure its substance? Or are forces themselves just mathematical descriptions of how empty space behaves? Stay with me, because we're about to go deeper than you ever imagined. Let's talk about what forces actually are, and I promise you, this will bend your brain. In physics, we've identified 4 fundamental forces that govern everything in the universe: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Every single interaction you've ever experienced, every movement, every sensation, every change in the universe comes down to these four forces. But what is a force, really? Is it a thing? Does it exist in the way a chair exists? Here's the shocking truth. Forces aren't objects. They're not made of matter. They're relationships. They're mathematical descriptions of how things interact across space and time. Think of it like this. When you see two people fall in love, the love isn't a physical object you can hold. It's a relationship, a pattern of interaction. Forces are similar. They're the invisible patterns that govern how particles relate to each other across the void of space. Michael Faraday, working in the 1830s and 1840s, revolutionized our understanding of forces by introducing the concept of fields. He proposed that forces don't act directly between objects, but instead create invisible fields in space that mediate interactions. When you hold a magnet, you're not just holding a piece of metal. You're holding an object that generates an invisible electromagnetic field extending through space around it. Place iron filings near a magnet, and you can actually see the shape of this field. But here's the critical question. Is the field real? Is it a physical thing? Or is it just a mathematical convenience we use to describe how the magnet influences space around it? In the 1860s, James Clerk Maxwell took Faraday's ideas and turned them into mathematical equations that unified electricity and magnetism into a single electromagnetic force. His equations showed that electromagnetic fields could propagate through empty space as waves, traveling at exactly the speed of light. This led him to a stunning conclusion. Light itself is an electromagnetic wave. What you see with your eyes is literally the oscillation of electromagnetic fields. Here's what will blow your mind. Everything you've ever seen, every color, every image, every face you've ever looked at isn't really what's out there. You're not seeing objects. You're detecting electromagnetic waves that bounced off objects. Your eyes are receivers tuned to a narrow band of electromagnetic frequencies, and your brain constructs images from this data. Vision isn't passive observation. It's active interpretation of force fields. The world you see is a simulation created by your brain based on electromagnetic information. You're not seeing reality directly. You're seeing your brain's best guess about what's causing those electromagnetic waves to reach your eyes. Now let's get even weirder. In quantum physics, forces are mediated by particles called force carriers. For electromagnetism, the force carrier is the photon. When two electrons repel each other, they're actually exchanging virtual photons. These virtual particles pop into existence for infinitesimally short periods of time, carry force information between particles, and then disappear back into the quantum vacuum. You read that correctly. The forces holding you together, keeping you from falling through your chair, making atoms stick together to form molecules, are mediated by particles that don't continuously exist. They're temporary fluctuations in quantum fields that appear and disappear faster than anything can measure. Richard Feynman, one of the greatest physicists of the 20th century, developed quantum electrodynamics in the 1940s, which describes exactly how these virtual particles mediate forces. He won the Nobel Prize in 1965 for this work. But even Feynman admitted that nobody truly understands quantum mechanics. He famously said, "I think I can safely say that nobody understands quantum mechanics." Think of it like this. Imagine two people on ice skates throwing a basketball back and forth. As person A throws the ball to person B, person A gets pushed backward. As person B catches the ball, person B gets pushed backward. The ball mediates a force between them. Now imagine the basketball only exists while it's in flight and disappears when caught and thrown. That's essentially what virtual photons do, except on a scale billions of times smaller and faster than anything in our everyday experience. Now we need to talk about quantum field theory, because this is where the simulation aspect becomes impossible to ignore. In modern physics, particles themselves aren't considered fundamental. What's fundamental are fields, quantum fields that permeate all of space. Imagine the universe as an infinite ocean. In this ocean, there are different types of waves: electron waves, photon waves, quark waves, and so on. What we call particles are actually localized excitations in these fields, like little whirlpools in the ocean. An electron isn't a tiny ball of matter. It's a vibration in the electron field. A photon is a vibration in the electromagnetic field. The physical world, according to quantum field theory, is just various quantum fields vibrating in different patterns. Matter is vibration. Forces are interactions between vibrations. You are a pattern of vibrations in quantum fields, experiencing other patterns of vibrations in quantum fields. But here's the question that should keep you up at night. What are these fields made of? What's vibrating? And if everything is just field vibrations, what does that make reality? Are we living in what amounts to a cosmic simulation running on quantum field mathematics? The answer is going to challenge everything you think you know about existence. In 1928, Paul Dirac derived an equation describing the behavior of electrons that respected both quantum mechanics and special relativity. But his equation had a strange property. It predicted that for every particle, there should be a corresponding antiparticle with opposite charge. In 1932, Carl Anderson discovered the positron, the antimatter counterpart to the electron, exactly as Dirac's equations predicted. This discovery revealed something profound. The mathematics predicts reality. The universe seems to be following mathematical rules, so precisely that we can predict the existence of things we've never seen just by following the math. It's as if the universe is running a mathematical simulation of itself. Think of it like this. When you play a video game, everything in that game follows rules programmed by the developers. Physics engines determine how objects move, interact, and behave. The characters in the game don't know they're following programmed rules. From their perspective, it's just reality. What if our universe is similar? What if the mathematical laws of physics are like the source code of reality? But there's a crucial difference. In a video game, there's hardware running the simulation, processors computing the rules. What would be the hardware running our universe? Or does the universe not need hardware? Could mathematics itself be generative, bringing reality into existence simply by being consistent? Let's return to the emptiness and really grapple with it. I mentioned earlier that atoms are 99.9999999% empty space. Let me put that in perspective. If you removed all the empty space from all the atoms and all the humans on Earth, the remaining matter would fit into a sugar cube. 7 billion people compressed into a sugar cube, because that's how much actual stuff there is in all of us combined. Now extrapolate that to everything. The planet you're standing on is almost entirely empty space. The sun is almost entirely empty space. The galaxy is almost entirely empty space, filled with force fields creating the illusion of substance. What does this emptiness mean philosophically? If matter is mostly void, what is substance? What does it mean for something to be real? Here's where it gets truly mind-bending. Even the solid parts, the nucleus and electrons, aren't really solid. Remember, electrons are vibrations in the electron field. Quarks that make up protons and neutrons are vibrations in quark fields. When you zoom all the way down, there's no solid stuff anywhere. It's patterns all the way down. The philosopher and physicist Ernst Mach, in the late 19th century, argued that all we can ever know are our sensations and the relationships between them. We never experience matter directly. We only experience the effects of forces on our sensory organs. What we call matter is just a conceptual convenience, a label for the patterns of forces we experience. Think of it like this. Imagine you're watching a movie. You see characters, objects, events unfolding on screen. But if you look closely at the screen, there's no actual character there, just pixels arranged in patterns that create the illusion of a character. Your brain integrates these patterns into a coherent narrative. Similarly, what you call physical objects might just be patterns of forces that your brain integrates into the experience of solidity. Here's what should absolutely blow your mind. Every atom in your body is replaced over time. The atoms that make up your heart today are not the same atoms that made up your heart 7 years ago. You've been completely recycled at the atomic level, yet you're still you. Your identity, your memories, your personality persist, even though the material substrate has been completely swapped out. This means you aren't the atoms. You're the pattern. You're the particular arrangement and interaction of forces that maintains coherence over time, even as the underlying components change. You're a process, not a thing. You're a verb, not a noun. Now let's talk about what happens when forces interact with each other at the quantum level, because this is where simulation theory becomes almost unavoidable. In quantum mechanics, particles don't have definite properties until they're measured. An electron doesn't have a definite position or momentum until you observe it. Before observation, it exists in what's called a superposition, a state where it simultaneously occupies multiple possibilities. The double-slit experiment, first performed by Thomas Young in 1801 and refined countless times since, demonstrates this perfectly. When you fire electrons one at a time through two slits, each individual electron somehow goes through both slits simultaneously, interfering with itself to create a pattern on the detector screen. But if you try to observe which slit the electron goes through, the interference pattern disappears, and the electron behaves like it went through only one slit. This isn't a matter of measurement disturbing the system. The very act of observation seems to collapse the wave function, forcing reality to choose one outcome from many possibilities. Before observation, the electron exists as a wave of probabilities. After observation, it becomes a particle with a definite location. Think about what this means. Reality isn't determined until something observes it. The universe seems to render itself like a video game, computing only what's being observed and leaving everything else in probabilistic limbo. If nobody's observing the moon, is it really there in a definite state, or does it exist as a cloud of probabilities until someone looks? This question has haunted physicists for a century, and the answer is about to challenge your entire conception of physical reality. The observer effect in quantum mechanics suggests that consciousness or observation plays a fundamental role in actualizing reality. This led some physicists, including Nobel laureate Eugene Wigner, to propose that consciousness might be what collapses the wave function, turning possibilities into actualities. But what counts as an observer? Does it require consciousness? Can a camera collapse a wave function? Can a molecule? Where do you draw the line? The Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg in the 1920s, essentially throws up its hands and says that quantum systems don't have definite properties until measured. But what constitutes measurement isn't clearly defined. It's a practical interpretation that works for calculations, but doesn't explain what's actually happening. The many worlds interpretation, proposed by Hugh Everett in 1957, takes a different approach. It suggests that all possible outcomes actually occur, but in different branches of reality. When you measure an electron's position, the universe splits. In one branch, you observe it here. In another branch, you observe it there. Both realities exist simultaneously in separate universes that can never interact. Think of it like this. Every time quantum randomness could go one way or another, the universe branches like a tree. You experience one path through this infinitely branching structure, but countless versions of you experience all the other paths. Right now, in other branches, versions of you made different choices, observed different outcomes, live in universes with slightly or dramatically different histories. If many worlds is correct, then the universe is constantly simulating every possible outcome of every quantum interaction. Reality isn't a single simulation. It's an infinite number of simultaneous simulations, all running in parallel. But there's another interpretation that's even more radical. The participatory universe model proposed by John Archibald Wheeler. Wheeler suggested that observers and the universe co-create each other through a cosmic feedback loop. The universe gives rise to observers through billions of years of evolution, and observers give the universe its reality through observation. Wheeler imagined the universe as a self-excited circuit. In the beginning, there were only quantum probabilities. But as the universe evolved and became complex enough to produce observers, those observers began collapsing wave functions, actualizing reality. The past, in a sense, is created retroactively by present observations. This leads to the truly mind-bending concept called the delayed choice experiment. Physicist John Wheeler proposed a thought experiment where choices made in the present could influence what happened in the past. Variations of this experiment have actually been performed, and the results confirm Wheeler's prediction. The way you set up a measurement now can determine how a photon behaved billions of years ago. Think of it like this. Imagine playing a video game where the game doesn't render past events until you turn around and look. The moment you turn, the game quickly generates what must have happened behind you to be consistent with the current game state. Wheeler's delayed choice experiments suggest the universe might work similarly, constructing the past retroactively based on present observations. Here's what should absolutely melt your brain. If the present can influence the past through observation, then the early universe, which existed before any observers, didn't have a definite history. The observations we make now could be actualizing what happened 13.8 billion years ago. The Big Bang might not have had a definite form until observers evolved to ask questions about it. Reality isn't a film that played in one way. It's a quantum superposition of all possible histories that gets narrowed down by observation. You're not just observing a pre-existing universe. You're participating in creating its history through the act of observation. Now let's talk about the force that started this whole discussion. Gravity. Gravity is the force you're most intimately familiar with. It's pulling you down into your chair right now. You experience it every moment of your life. Yet gravity is the least understood of all the fundamental forces, and its nature might completely overturn everything we've discussed so far. Unlike the other three forces, gravity doesn't seem to have a force carrier that fits into the quantum framework. Physicists have hypothesized a particle called the graviton that would mediate gravity, the way photons mediate electromagnetism. But gravitons have never been detected, and many physicists doubt they can be detected even in principle. Albert Einstein revolutionized our understanding of gravity in 1915 with his general theory of relativity. He showed that gravity isn't a force at all in the traditional sense. It's the curvature of spacetime itself. Mass and energy tell spacetime how to curve, and curved spacetime tells matter how to move. Think of it like this. Imagine a stretched rubber sheet. If you place a bowling ball in the center, it creates a depression. Now, if you roll a marble nearby, it will spiral toward the bowling ball, not because the bowling ball is pulling it with a force, but because the marble is following the curved surface. Gravity works similarly. The Earth curves space-time around it, and you follow that curvature. You're not being pulled down. You're following the straightest possible path through curved space-time. But here's where it gets absolutely wild. If gravity is just curved space-time, and space-time is the fundamental stage on which reality plays out, then what is space-time made of? Is space-time itself a thing, or is it just another mathematical description? And if space-time can be curved and warped, what's doing the curving? What's the medium? The answer to this question might reveal that space and time themselves are simulated. Modern theories in quantum gravity suggest that space-time itself might be emergent, not fundamental. Just as temperature emerges from the average motion of molecules, but isn't fundamental at the molecular level, space-time might emerge from some deeper quantum structure. String theory, developed over the past several decades, proposes that the fundamental constituents of reality aren't point particles, but tiny vibrating strings of energy. Different vibration patterns create different particles. An electron is one vibration pattern, a quark is another, a photon is yet another. In string theory, gravity emerges from a particular vibration pattern of strings. But strings vibrate in 10 or 11 dimensions, not the 4 dimensions of spacetime we experience. Where are these extra dimensions? String theorists propose they're curled up at scales so small we can't detect them, like a garden hose that looks one-dimensional from far away, but reveals its circular cross-section when you zoom in. Loop quantum gravity, another approach to quantum gravity, suggests that spacetime itself is quantized, made of discrete units called Planck-length loops. Space isn't continuous. It's pixelated at the smallest scale, about 10 to the power of -35 meters. Time is similarly quantized into Planck time intervals of about 10 to the power of -43 seconds. Think of it like this. A computer screen appears to show smooth images, but zoom in and you see individual pixels. Loop quantum gravity suggests that if you could zoom into spacetime far enough, you'd see the pixels of reality, discrete units beyond which no further subdivision is meaningful. If spacetime is quantized, if it's made of discrete units like pixels on a screen, then the simulation hypothesis becomes almost impossible to dismiss. The universe would literally be running on a substrate that has a minimum resolution, just like a computer simulation has limited resolution determined by its computational power. But here's the question that should haunt you. If spacetime is emergent, arising from something more fundamental, what is that more fundamental thing? What is the substrate beneath the substrate? Some physicists, including Nobel laureate Gerard 't Hooft and Leonard Susskind, have proposed the holographic principle. This principle suggests that all the information contained in a volume of space can be encoded on the boundary of that volume. The universe as you experience it in 3 dimensions might be a holographic projection of information encoded on a 2-dimensional surface. Think of it like this. A hologram is a flat surface that contains information about a 3-dimensional image. When you shine the right light through it, the 3-dimensional image appears. The holographic principle suggests that our 3-dimensional universe works similarly, that all of spacetime and everything in it is information projected from a lower dimensional boundary. If this is true, then the forces you experience, the solidity you feel, the sense of depth and dimension are all emergent properties of information encoded elsewhere. You're experiencing a projection, a simulation generated from data on the boundary of the universe. Now let's bring this back to you, to your life, to what this means for your daily experience of reality. You wake up in the morning, brush your teeth, eat breakfast, go about your day. Every sensation feels undeniably real. The warmth of sunlight on your skin, the taste of coffee, the feeling of hugging someone you love. These experiences seem to be direct encounters with physical reality. But based on everything we've discussed, what's actually happening? The sunlight you feel is electromagnetic radiation, photons generated by nuclear fusion in the sun, traveling through empty space for 8 minutes and triggering chemical reactions in your skin cells. Your nerves detect these reactions and send electrical signals to your brain. Your brain interprets these signals as warmth. You're not feeling the sun. You're feeling your brain's interpretation of electromagnetic forces interacting with force fields in your skin. The experience is real, the sensation is real, but it's once removed from whatever is actually out there. Here's what should change your entire worldview. You've never experienced reality directly, ever. Every sensation, every perception, every thought you've ever had is your brain's simulation of what it thinks is happening based on electrical and chemical signals. Your brain is a prediction machine, constantly creating a model of the world and updating it based on sensory input. When you see red, you're not seeing an objective property called redness. You're seeing your brain's response to electromagnetic waves with a wavelength of about 700 nanometers. Red doesn't exist out there. It's created in your head. Everything you experience is created in your head, including the experience of having a head. Let's talk about the implications for free will, because if you're a pattern of forces following mathematical laws, where does choice come in? This is the hard problem that philosophers and neuroscientists grapple with. Your brain is made of atoms following the laws of physics. Every thought, every decision, every feeling is the result of electrochemical processes in neurons. These processes follow deterministic laws at the macroscopic level and probabilistic laws at the quantum level. There doesn't seem to be room for a you that stands apart from these processes making truly free choices. Some scientists, like Robert Sapolsky, argue that free will is an illusion, that everything you do is determined by prior causes stretching back to the Big Bang. You feel like you're making choices, but that feeling is itself just another determined process. Others argue that quantum indeterminacy provides room for free will, that the randomness at the quantum level bubbles up to create genuine openness in the future. But is randomness really freedom? If your choices are random quantum fluctuations, are they any more yours than if they were determined? Think of it like this. Imagine a sophisticated robot programmed with complex decision-making algorithms. From the inside, running those algorithms might feel exactly like making a free choice. How do you know you're not in that situation? How do you know the feeling of free will isn't just the subjective experience of deterministic or random processes running in your brain? But here's a different way to think about it that might be more empowering. Maybe the question isn't whether you have free will, but what you are. If you identify as the pattern of forces, the process, the information structure that your brain creates and maintains, then your choices are free in the sense that they're not imposed from outside. They arise from the complexity of your own processing. You're not separate from the forces. You are forces arranged in a particular pattern. When you make a choice, the universe is making a choice through the particular configuration of forces that constitutes you. Your will is part of the universe's unfolding. From this perspective, the question of free will dissolves. You don't have freedom from the laws of physics. You have freedom through them. The laws of physics are what make you possible, what allow the incredible complexity of human consciousness to exist. Now we need to talk about consciousness, because it's the elephant in the room we've been dancing around. Everything we've discussed, forces, fields, particles, space-time, these are descriptions of the physical universe. But you experience something else. Qualia, the subjective, qualitative feel of experiences. When you see red, there's the objective fact of 700 nanometer wavelength light hitting your retina. And then there's the subjective experience of redness. That experience, that feeling of what it's like to see red, can't be fully captured by any physical description. This is called the hard problem of consciousness, articulated by philosopher David Chalmers in the 1990s. Some neuroscientists believe that consciousness is an emergent property of complex information processing. Get enough neurons firing in the right patterns, and consciousness appears. But this doesn't explain why there's something it's like to be those neurons firing. Why isn't all this information processing happening in the dark, so to speak? Why does it feel like something? Others, including some physicists, have proposed that consciousness might be fundamental to the universe, not emergent. Physicist Max Tegmark has explored the idea that certain patterns of information processing generate consciousness, and these patterns might be ubiquitous. Giulio Tonani's integrated information theory suggests that any system that integrates information has some degree of consciousness. Think of it like this. We know matter and energy are fundamental. We know forces are fundamental. What if consciousness is fundamental too? What if every quantum interaction has an infinitesimal element of experience associated with it? And complex arrangements like brains create complex consciousness by integrating these micro-experiences? This view, called panpsychism, is gaining traction among some serious thinkers. If it's true, then the forces we've been talking about aren't just blind mechanical pushes and pulls. They might have an inner aspect, an experiential dimension. The universe wouldn't just be a simulation of forces. It would be forces experiencing themselves. And you, as a conscious being, might be the universe's way of knowing itself. Philosopher Thomas Nagel wrote a famous essay called, "What is it like to be a bat?" arguing that even if we knew everything about bat neurology, we couldn't know what it's like to experience the world as a bat. The subjective experience is irreducible to objective description. If consciousness is fundamental rather than emergent, this makes sense. You can describe the physical processes all you want, but you can't capture the experience because experience is ontologically distinct from physical description. It's not that we don't yet have the right physical theory. It's that physical theory, by its nature, describes the objective, third-person view. Experience is inherently first-person. Now here's why this connects back to simulation theory. If consciousness is fundamental, and the physical world is a pattern of forces governed by mathematical laws, then maybe consciousness is the substrate running the simulation. Maybe the universe is fundamentally experiential, and the physical laws are patterns that organize consciousness. Think of it like this. In your dreams, you experience a world that seems physical. You walk around, touch objects, interact with people, but the whole thing is generated by your consciousness. There's no physical dream stuff. It's all patterns in your mind, creating the experience of physicality. What if the waking world works similarly, but at a cosmic scale? What if the universe is consciousness dreaming itself into apparent physical existence? Here's the truly staggering possibility. If the universe is fundamentally experiential, and physical laws are patterns organizing consciousness, then the hard boundary between you and the rest of the universe might be illusory. You might not be a separate consciousness observing an external physical world. You might be one localized expression of a universal consciousness experiencing itself from countless perspectives simultaneously. When you look at another person, you might be the universe looking at itself. When you contemplate the stars, you might be the cosmos becoming aware of its own vastness. The sense of separation, of being an isolated observer in a foreign physical world, might be the ultimate illusion. Let's zoom out even further and talk about information, because increasingly, physicists are realizing that information might be more fundamental than matter or energy. John Archibald Wheeler, who we mentioned earlier, coined the phrase "it from bit," suggesting that every physical thing derives from information, from binary choices, from yes or no questions. In quantum mechanics, information plays a strange role. Quantum information can't be copied due to the no-cloning theorem. Quantum entanglement allows information to be correlated across space in ways that seem to violate our intuitions about locality. Black holes apparently destroy information, creating the black hole information paradox that's plagued physics for decades. In the 1970s, Jacob Bekenstein and Stephen Hawking discovered that black holes have entropy, a measure of information content. More surprisingly, a black hole's entropy is proportional not to its volume, but to the surface area of its event horizon. This was one of the first hints leading to the holographic principle we discussed earlier. Think of it like this. Entropy measures how many different microscopic configurations could produce the same macroscopic state. For ordinary objects, entropy is proportional to volume, because more volume means more particles, means more possible configurations. But for black holes, the maximum entropy is determined by surface area. This suggests that the interior volume of a black hole is somehow redundant, that all the information is encoded on the surface. If black holes follow this principle, maybe everything does. Maybe the three-dimensional volume of any region of space contains no more information than could be encoded on its two-dimensional boundary. The interior would be a holographic projection of the boundary information. Now, if reality is fundamentally informational, what does that mean for the nature of forces? Forces would be the rules governing how information updates and evolves. The electromagnetic force would be the rule for how electrical charge information propagates. Gravity would be the rule for how mass-energy information curves spacetime information. You, as a conscious being, would be a particular arrangement of information that's complex enough to process and experience other information. Your body is information encoded in DNA and expressed through proteins. Your memories are information encoded in synaptic connections. Your thoughts are information flowing through neural networks. When you die, the information doesn't disappear. It just disperses and reorganizes. The atoms that made up your body continue existing, carrying information forward into new structures. The impact you had on the world, the memories others have of you, the consequences of your actions, all that information persists and propagates. From an informational perspective, death isn't annihilation, it's transformation. The pattern that was you dissolves, but the information redistributes into new patterns. But here's something that will really twist your mind. If the universe is fundamentally informational, and information is fundamentally mathematical, then the universe might be nothing more than a mathematical structure that exists necessarily. Physicist Max Tegmark has proposed the mathematical universe hypothesis, that physical reality is a mathematical structure, and all mathematical structures exist. We find ourselves in this particular mathematical structure because it's complex enough to support conscious observers. Think of it like this. Mathematical truths exist necessarily. 2 + 2 = 4 in all possible universes. Mathematical structures don't need to be created. They exist timelessly in a Platonic realm of abstract forms. If our universe is a mathematical structure, it doesn't need a creator or a cause. It exists necessarily by virtue of being a consistent mathematical object. Under this view, the Big Bang isn't the creation of the universe. It's just the bottom boundary of a mathematical structure in time. Asking what came before the Big Bang is like asking what's north of the North Pole. The question doesn't make sense within the structure. So the ultimate question becomes, is mathematics discovered or invented? When mathematicians derive theorems, are they uncovering pre-existing truths, or are they creating conceptual structures? And if they're discovering pre-existing truths, where do those truths exist? The answer might determine whether the universe is a simulation or the only thing that's fundamentally real. Let's talk about emergence, because it's the phenomenon that allows simple rules to generate extraordinary complexity. And it might be the key to understanding how a universe of forces creates everything from galaxies to consciousness. Emergence occurs when a system exhibits properties and behaviors that its components don't have individually. Water molecules aren't wet. Wetness emerges from the interactions of countless molecules. Individual neurons don't think. Thinking emerges from the interactions of billions of neurons. The rules governing individual components can be simple, but when you have massive numbers of components interacting, complex behaviors emerge that seem qualitatively different from the underlying rules. Think of it like this. The game of chess has extremely simple rules. Each piece moves in a specific way. That's it. But from these simple rules emerges extraordinary complexity. After just 4 moves by each player, there are over 288 billion possible positions. The space of possible games is larger than the number of atoms in the observable universe. If simple chess rules generate that much complexity, imagine what the laws of physics generate. You start with quantum fields and forces following mathematical laws. From this, atoms emerge. From atoms, molecules emerge. From molecules, self-replicating chemicals emerge. From self-replicating chemicals, life emerges. From life, nervous systems emerge. From nervous systems, consciousness emerges. Each level has properties unpredictable from the level below. You can't predict the properties of water by studying individual H2O molecules in isolation. You can't predict the plot of Hamlet by studying individual words. The whole is genuinely more than the sum of its parts. This poses a fascinating question. If consciousness emerges from neural complexity, and neural complexity emerges from chemistry, and chemistry emerges from quantum physics, is there a level below quantum physics from which it emerges? String theory and loop quantum gravity suggest yes. But even those might emerge from something deeper. Some physicists speculate about an infinite regression of turtles, all the way down. Others propose that at some point, you hit bottom, a level that's truly fundamental and doesn't emerge from anything else. But here's a third possibility. It's deeply strange. Maybe reality is circular. Maybe quantum physics emerges from consciousness, and consciousness emerges from quantum physics. Maybe the universe bootstraps itself into existence through circular causation. Think of it like this. Imagine a strange loop where A causes B causes C, and C causes A. There's no starting point. The loop is self-sustaining. Consciousness might need a physical brain to exist, and physical brains might need consciousness to actualize from quantum probabilities. Neither is more fundamental. They co-create each other. Here's what should absolutely explode your understanding of causation. Physicist John Wheeler proposed that the universe might be a participatory, self-excited system. In the early universe, quantum fluctuations were in superposition. As the universe evolved complexity and eventually produced observers, those observers began making measurements, collapsing wave functions, actualizing reality. But in doing so, they retroactively determined which quantum fluctuations in the early universe became actual, including the ones that led to their own existence. The universe observes itself into being through a cosmic bootstrap operation. Effect precedes cause, and cause precedes effect in a self-consistent loop. Time becomes less like a line and more like a circle or spiral. Let's connect this back to simulation theory. If the universe can bootstrap itself through circular causation, it doesn't need an external simulator. It simulates itself. The mathematical laws are the simulation code. The quantum fields are the variables being computed, and conscious observers are the outputs that feed back into the inputs, sustaining the whole structure. You're not living in a simulation created by some advanced civilization. You're living in a self-simulating mathematical structure that exists necessarily and experiences itself through the consciousness it generates. This resolves the infinite regress problem. If we're in a simulation, who simulated the simulators? If the simulators are also simulated, who simulated them? With a self-simulating universe, there's no regress. The universe is the only thing that exists, and it sustains itself through its own mathematical consistency and the observations of the consciousness it contains. Now we need to talk about time, because the nature of time is central to understanding whether the physical world is a simulation of forces. You experience time as flowing, as a river carrying you from past through present into future. But is that what time actually is? Einstein's theory of relativity revealed something shocking. Time is relative. Depending on your speed and gravitational field, time passes at different rates. Two observers moving relative to each other will disagree about which events are simultaneous, how much time has elapsed, even about the order of events in some cases. Moreover, relativity treats time as a dimension similar to the three spatial dimensions. Spacetime is a four-dimensional structure where all moments exist equally. The past hasn't gone anywhere. It's still part of the spacetime manifold. The future isn't yet to be created. It already exists as part of the structure. This view is called the block universe or eternalism. Time doesn't flow. You flow through time, or rather, your consciousness is a cross-section of a four-dimensional organism stretched through time, and that cross-section appears to move. Think of it like this. Imagine a DVD of a movie. All the frames exist simultaneously on the disc. When you play the movie, you experience the frames in sequence, creating the illusion of motion and change. But from outside the movie, all moments are equally real and present. The block universe suggests reality works similarly. All of history and future exists simultaneously in the four-dimensional space-time structure. If the block universe is correct, then the forces acting in the universe aren't pushing things forward through time. They're creating patterns in the four-dimensional structure. Your entire life, from birth to death, is a four-dimensional structure, a world line through space-time. The forces acting on you throughout your life create the shape of this world line. When you think about it this way, causation becomes less about one event making another happen, and more about how events are correlated across the four-dimensional structure. Causes don't precede effects in any absolute sense. They're just earlier parts of space-time patterns that determine later parts of the same patterns. Your conscious experience of moving through time might be an illusion generated by the fact that memories are encoded in earlier parts of your world line and accessed by later parts. Each moment of consciousness contains memories of previous moments, creating the impression of having come from the past. But all moments exist simultaneously in the eternal now of the block universe. But here's where it gets weird. If all moments exist simultaneously, why do you experience only one moment at a time? Why don't you experience your entire life at once? Some physicists and philosophers suggest that you actually do experience your entire life simultaneously from a timeless perspective. But the structure of consciousness is such that individual moments can only access their immediate temporal neighbors. Each moment of consciousness is like a frame in a film. The frame can only know about adjacent frames through continuity, even though all frames exist simultaneously. Think of it like this. Imagine a novel. All the words exist simultaneously on the pages, but you read them sequentially. The characters in the novel, if they were conscious, would experience their story unfolding in time, even though from outside the novel, all moments of the story exist simultaneously. You might be in a similar situation, a character in the four-dimensional novel of spacetime, experiencing sequential moments, even though all moments exist eternally. This raises a profound question. If all moments of time exist eternally, then your death is just as eternal as your life. The moment you're experiencing right now exists forever as part of the space-time structure. You reading this right now are eternal. Not in the sense of lasting forever into the future, but in the sense that this moment is permanently part of the fabric of reality. Death doesn't erase you from existence. It's just the boundary of your four-dimensional structure. You're as real after death as you are before birth, which is to say, moments outside your world line exist, but they're not you. Now let's talk about something that's deeply puzzling and might offer the strongest evidence that we're in a simulation: the fine-tuning of physical constants. The laws of physics contain various constants, like the speed of light, the gravitational constant, the mass of the electron, and so on. These constants have very specific values. Here's what's weird. If you change these values even slightly, the universe becomes inhospitable to life. If the strong nuclear force were 5% stronger, all hydrogen would have fused into heavier elements in the early universe, and there would be no stars. If it were 5% weaker, complex atoms couldn't form. If the electromagnetic force were slightly different, atoms couldn't bond into molecules. If gravity were slightly stronger, stars would burn too quickly. If it were slightly weaker, stars wouldn't ignite. The cosmological constant, which governs the expansion rate of the universe, is fine-tuned to about 1 part in 10 to the power of 120. That's 1 followed by 120 zeros. It's a precision unmatched anywhere in physics. If it were larger, the universe would have expanded too rapidly for galaxies to form. If it were smaller, the universe would have collapsed back in on itself. Think of it like this. Imagine you're given a radio to find a specific frequency, but the dial is infinitely long, and the frequency you're looking for occupies only a tiny sliver. The odds of randomly landing on it are essentially zero. Yet we find the universe tuned precisely to the narrow range that allows life. There are several possible explanations for this fine-tuning. One is the anthropic principle. We observe these constants because we couldn't exist in a universe with different constants. Of course, we find ourselves in a life-permitting universe. We couldn't find ourselves anywhere else. It's selection bias. There might be countless universes with different constants, and we're in one of the rare ones that permits observers. This leads to the multiverse hypothesis. If there are infinite universes with different physical constants, then even the most improbable configuration will occur somewhere. We happen to be in one where the constants are right for life. But another explanation is that the constants aren't random. They were set deliberately by whoever or whatever created the simulation. If you were programming a universe simulation and wanted it to produce complexity and life, you'd carefully tune the parameters to make that possible. The fine-tuning is evidence of intentional design, not necessarily by a deity, but possibly by advanced simulators. Think of it like this. When game developers create a game world, they carefully tune the physics engine parameters to make the game playable and interesting. Gravity might be exaggerated for better jump mechanics. Damage values are balanced for fair gameplay. The universe's fine-tuning might be similar parameters set by designers to achieve particular outcomes. Physicist Paul Davies has argued that the fine-tuning is too remarkable to dismiss as coincidence. The universe seems to be rigged in favor of life and consciousness. Some interpret this as evidence of a creator god. Others see it as evidence of simulation. Still others accept it as brute fact, requiring no explanation. But here's a perspective that reconciles these views. If consciousness is fundamental, and the universe is consciousness experiencing itself, then the fine-tuning isn't accidental or externally imposed. It's self-tuning. The universe tunes itself to produce consciousness because the universe is consciousness unfolding its own potential. The constants aren't set by an external designer. They're intrinsic to a mathematical structure that necessarily includes consciousness. Just as mathematical truths like the Pythagorean theorem don't need to be tuned, they follow necessarily from the axioms. The physical constants might follow necessarily from a deeper mathematical structure that we don't yet understand. Let's talk about one of the weirdest phenomena in physics: quantum entanglement. When two particles interact and then separate, they remain connected in a strange way. If you measure a property of one particle, you instantly know the corresponding property of the other particle, no matter how far apart they are. Einstein called this spooky action at a distance and thought it proved quantum mechanics was incomplete. He believed there must be hidden variables determining the particle's properties all along. But in 1964, physicist John Stuart Bell devised a test to determine whether hidden variables exist. Bell's theorem showed that if hidden variables existed, certain statistical correlations in measurements would be limited. Experiments testing Bell's inequalities have been performed thousands of times since the 1970s, and they consistently violate the limits that hidden variables would impose. The correlations are stronger than any local hidden variable theory allows. This means that either the universe's fundamentally non-local influences travel faster than known. Light or the particles don't have definite properties until measured. Think of it like this. Imagine you have a pair of magic coins. You separate them by vast distances, and when you flip one and get heads, the other instantly becomes tails, and vice versa. Moreover, this correlation holds no matter what angle you orient the coins before flipping. The coins seem to be communicating instantaneously, or they're not really separate coins, but aspects of a single quantum system. Quantum entanglement suggests that the universe isn't made of separate parts. At a fundamental level, everything is connected in a unified whole. The appearance of separate objects is an illusion created by how we observe the quantum wave function. This has profound implications for simulation theory. In a computer simulation, objects are fundamentally separate data structures that interact according to programmed rules. But quantum entanglement suggests reality doesn't work that way. Reality is fundamentally holistic, with apparent separations emerging only through observation. Some interpretations of quantum mechanics, like relational quantum mechanics developed by Carlo Rovelli, suggest that properties of quantum systems only exist relative to other systems. There's no absolute state of a particle. There's only its state relative to you, relative to another particle, relative to a measuring device. Reality is fundamentally relational, not substantial. Think of it like this. Imagine a social network where people only exist in relation to their connections. You're not an isolated individual with properties. You're a node in a network of relationships. Your properties, your role, your status, your identity are defined by how you relate to others. Quantum mechanics suggests reality works similarly. Particles are nodes in a vast network of quantum relationships. Here's the question that should keep you awake. If reality is fundamentally relational, who are you in relation to? The entire universe? Other conscious beings? And if you're defined by your relationships, what happens to you when those relationships change or dissolve? The answer might reveal that your individual existence is far more interconnected with everything else than you ever imagined. Let's pull together everything we've discussed and see what picture emerges. The physical world appears solid, but it's mostly empty space. The apparent solidity comes from forces' electromagnetic repulsion between electron clouds. But forces aren't things. They're mathematical relationships describing how quantum fields interact. Quantum fields permeate all space and give rise to particles as localized excitations. But these fields themselves might be emergent from an even more fundamental level, possibly pure information or mathematical structure. Spacetime, the stage on which everything plays out, might also be emergent, arising from quantum entanglement or holographic encoding of information. Observation plays a crucial role in actualizing reality from quantum probabilities. The universe doesn't exist in a definite state until observed, suggesting that consciousness isn't separate from physical reality, but integral to it. The fine-tuning of constants might indicate that the universe is self-organizing toward consciousness, or that consciousness is fundamental, and physics is how consciousness structures itself. Time might not flow. All moments might exist eternally in a four-dimensional block universe. Your experience of moving through time might be the sequential activation of consciousness moments that all exist simultaneously. Forces don't push things forward through time. They create patterns in the eternal structure of space-time. So is the physical world a simulation of forces? In a sense, yes. The world you experience is constructed by your brain from sensory data about forces. The forces themselves are descriptions of how quantum fields interact according to mathematical laws. And the quantum fields might be emergent from pure information or mathematical structure. You've never touched reality directly. You've experienced a simulation created by your nervous system, rendering forces into sensations, qualia, the feeling of existence. The universe might be simulating itself through its own mathematical consistency, with consciousness as both the output and the observer that actualizes the simulation. But here's the twist. Calling it a simulation implies it's not real. That's wrong. It's the only reality. Whether you call it a simulation, a mathematical structure, a field of consciousness, or simply the universe, it's the ground of all existence. There's nothing more real behind it. Think of it like this. When you realize a rainbow isn't a physical object, but light refracted through water droplets, the rainbow doesn't become less beautiful or less real as an experience. It's still there, still spectacular. You just understand it differently. Similarly, realizing the physical world is forces and fields and consciousness interacting doesn't make it less real. It makes it more wondrous. The implications for your life are profound. If you're a pattern of forces, then your substance is dynamic, not static. You're constantly changing, constantly being remade, constantly in flux. The atoms that make you up are replaced over time, but you persist as a pattern, an information structure, a process rather than a thing. This means you have tremendous plasticity. You're not stuck being who you are. The patterns that constitute you can be rewired, reshaped, reformed. Your habits, your beliefs, your personality, All of these are patterns in neural networks that can change. You're not a fixed entity. You're a verb, not a noun, an ongoing process of becoming. It also means you're deeply interconnected with everything else. The forces that make you up are the same forces making up everything else. The atoms in your body were forged in ancient stars. The oxygen you breathe was exhaled by plants. The water you drink has been through countless organisms before you. You're not separate from nature. You're nature experiencing itself from a particular perspective. Here's the ultimate realization. If consciousness is fundamental, and you're a localized expression of universal consciousness, then when you die, the consciousness that you are doesn't disappear. It can't disappear because it's fundamental. What disappears is the particular pattern, the specific configuration that created your unique perspective. But the consciousness itself, the awareness, the capacity for experience, that's eternal because it's the ground of all being. You might not persist as you after death, but the consciousness that was having your experience continues, diffusing back into the universal consciousness that temporarily localized as you. Think of it like this. Ocean waves rise and fall. Each wave has a unique shape, a temporary identity. When the wave crashes on the shore, the wave disappears, but the water doesn't. It returns to the ocean. You might be like a wave in an ocean of consciousness, a temporary configuration that returns to the source. So how should you live knowing all this? How should it change your perspective on daily life? Here are some thoughts. First, cultivate wonder. The fact that empty space arranged in patterns of forces creates the richness of experience you enjoy is miraculous. The coffee you taste, the music you hear, the love you feel, all of it emerges from mathematical relationships between quantum fields. That's not reductive. It's elevating. The universe has figured out how to experience itself, and you're one of its experiences. Second, recognize your interconnectedness. The boundaries between you and the rest of reality are far more permeable than they seem. You're not an isolated consciousness in a foreign universe. You're the universe becoming conscious of itself from a particular vantage point. What you do to the environment, you do to yourself. What you do to others, you do to yourself. There's no hard separation. Third, embrace change. You're not a static object, but a dynamic process. The patterns that constitute you are constantly updating. This means you can change your habits, heal from trauma, learn new skills, develop new perspectives. Your brain is plastic. Your personality is fluid. Your potential is vast. Fourth, question everything. The fact that reality is so different from how it appears should make you skeptical of surface appearances in all areas of life. Cultural assumptions, political ideologies, personal beliefs, all of these might be as illusory as the solidity of matter. Dig deeper, question harder, seek truth beyond appearances. Fifth, live fully. If the block universe is correct, your life exists eternally as a four-dimensional structure in spacetime. Every moment you're experiencing right now is permanent, forever part of the cosmic sculpture. Make it count. Make it beautiful. Make it meaningful. You're creating eternal art with your choices. Sixth, be kind. If we're all localized expressions of one universal consciousness experiencing itself from different perspectives, then kindness to others is ultimately self-kindness. When you help someone, you're helping yourself. When you cause suffering, you're causing yourself suffering. The golden rule isn't just moral advice. It might be ontological truth. Let me share a meditation practice that can help you experientially grasp what we've discussed. Sit comfortably, close your eyes, and focus on your breath. Notice the sensation of breathing. Now ask yourself, where exactly is the boundary between you and the air? The air enters your lungs. Oxygen diffuses into your blood, becomes part of you. Seconds ago, it was not you. Now it's you. Where did the transition happen? Notice the sounds around you. Sound waves are vibrations in air molecules hitting your eardrums, creating nerve signals interpreted as sound by your brain. The sound isn't out there or in here. It's a relationship between vibrations outside and processing inside. The boundary dissolves. Notice your thoughts. They arise without your conscious volition. You don't choose what thought comes next. It appears. Are your thoughts really yours? Or are you observing a process of thinking happening through the structure you call yourself? As you continue this meditation, you might start to feel that you're not an isolated thing, but a process, a pattern, a verb, not a noun. You're not in the universe. You're something the universe is doing. You're not experiencing reality. You're an experience reality is having. This realization can be profoundly liberating. The anxiety that comes from feeling like a separate, vulnerable entity in a hostile universe dissolves. You're not separate. You're home. You've always been home. You're the universe experiencing the joy of its own existence. So, is the physical world just a simulation of forces? Yes and no. It's forces, fields, mathematics, information, consciousness, all inextricably interwoven in a self-sustaining, self-actualizing, self-experiencing structure we call reality. It's a simulation in the sense that it's not what it appears to be, that solidity is illusion, that everything is far stranger than it seems. But it's not a simulation in the sense of being fake or secondary. It's the most real thing there is. It's the only thing there is. You are forces experiencing forces. You are the universe waking up to itself. You are consciousness playing the game of being a limited individual perspective, forgetting its infinite nature to experience the joy of rediscovery. And now you know. You can't unknow it. The veil has been lifted, and you've seen behind the curtain. The physical world isn't solid matter. It never was. It's dancing patterns of forces, quantum fields vibrating in mathematically precise ways, consciousness experiencing itself through an elaborate cosmic performance. The question isn't whether you're in a simulation. The question is, now that you know reality is so much stranger and more wondrous than it appears, what will you do with this knowledge? How will you live differently? How will you see yourself, others, and the world? You're not a passive observer of a pre-existing reality. You're an active participant in a reality that's continuously creating itself through observation and interaction. Every choice you make, every thought you think, every action you take, is the universe exploring its own possibilities through you. You matter, not in spite of being patterns of forces, but because of it. You're the universe's way of knowing itself, experiencing itself, marveling at itself. You're the cosmos becoming conscious. And that is the most profound, beautiful, awe-inspiring fact of existence. If this journey has blown your mind, if you're seeing reality differently now, hit that like button and share this video with someone who needs their perspective shattered. Subscribe for more deep dives into the nature of reality, consciousness, and existence. Drop a comment with your biggest takeaway or your lingering questions. Let's build a community of people who aren't afraid to question everything and explore the deepest mysteries of existence. Thank you for taking this journey with me. You've just spent 3.5 hours having your reality dismantled and reconstructed. That takes dedication. You're not just passively consuming content. You're actively engaging with the deepest questions humanity can ask. Remember, you're not in the universe. You are the universe. You're not experiencing reality. You are reality experiencing itself. You're not separate from the cosmic dance of forces. You are the dance. Now go out there and live like you know it. See through the illusion of solidity to the magnificent emptiness buzzing with forces. Feel your interconnection with everything. Embrace your nature as a dynamic process rather than a static thing. Question everything. Love deeply. Live fully. The simulation isn't imprisoning you. You are the simulation simulating itself into conscious existence. And that makes you the most extraordinary phenomenon in all of reality. Until next time, keep questioning, keep wondering, and keep being the universe waking up to itself.